continuing recording again for the next hour. So yeah, continue to discuss away. I don't know if we want to continue on with some of the questions, or it seemed like there was some really good discussion happening around variance and lineage determination. And yeah, anybody?
Did Nick run away? I have a question about his last statement.
Yeah, I'm still here.
So why would that be that you would have to validate the extraction from the beginning for a new viral variant? You wouldn't do that for any other PCR potential variant. So why would you have to do that for the wet lab if you say that I can sequence the virus?
Right, yep, yeah.
And that's the process, and then you're just validating the analytical portion of it.
Right, so the way we design most of our validations is we break it into two parts. We do like a large in silico validation to make sure like that portion works. And then we also take it from the very beginning, whether it's, you know, an isolate and take it through the entire process. And the way I do most of my validations is it's foolish to try to validate just one variant because there's millions and millions of combinations. Pick the ones that are in your area and maybe a couple that are really rare in your area, validate those and say, okay, if I can see the ones that are common in my area and the ones that are not, I'm assuming I can get everything in between. And then after that, you don't have to do any more validations.
Actually, Nick, I want to support the CAP would agree with you, and you can cite it, because the CAP approach to validation is that the lab needs to show that it's able to do that type of analysis instead of showing that you need to be able to detect every single possible variation. So, on your side.
Nick, my question is, what then for, let's just say you're doing CLIA validation of SARS-CoV-2 whole genome sequencing. What will be your validation material? Like, I think this is where a time that, you know, you have the traditional serial typing, you know, use the anti-sera as your gold standard when you validate some non-serotyping by whole genome sequencing. But I think we're at a place that we are the anti-sera for variant finding.
Right.
And one way I can think about is I read somewhere that there's this pseudo virus that people created to carry, you know, certain mutations for their experiment, you know, to see the neutralization activity. So that might be a good starting point, that, you know, you use man-made pseudo virus to validate the assay. But I'm, you know, open to suggestions.
Yeah. So I mean, ideally.
Do that for spike.
Yeah.
Sorry?
You'd be limited to spike protein.
No, the definition of the lineage include other mutations, non-stimulus mutations.
I'm saying with the pseudovirus, you'd be limited to validating spike variants.
Oh, you are saying their pseudovirus only have the spike protein?
Should be, yeah.
So it's not a true pseudo SARS-CoV-2 whole genome virus?
No, it's like a chimeric thing.
Oh, okay. Ugh, that's
it's bad. A good thought though. So if you're only looking at certain variants within the spike protein, then that's a good way to generate them quickly.
Yeah, but Glenn, the definition of variant is, you know, go beyond spike.
Yeah, and yeah, I completely agree. And I would argue that we're too focused on spike, but that's a different.
Yeah.
Yeah. So I think this is what I would do. If you go to BEI resources, they now have live COVID virus that you could probably also find that their sequence has been deposited into NCBI, and you could claim for CLIA that NCBI is going to be your gold standard for the sequence, and you could pull it out and prove metrics or whatever. And then if you don't want to grow it up, you know, well, you don't really have to grow it up. You do, you know, some amplification so you have more material. And then once you have that material and you say, okay, I have this sample from NCBI, I now have this much, you know, material in that, you know, and you do some quantitation assays for it or whatever. You can do quantitative PCR, or just, you know, qubit reading or whatever, and then take that particular reagent and use that to do, and that's one validation. through. You're going to use that one particular reagent, and then you say, okay, my one person is going to do an LOD on that, and they're going to use it on 2 different types of equipment. And I was just looking at you know, their first page of BEI has 20 or so different organisms, but without even opening it up and seeing if whatever the variants are. At that point, you're not caring for the sake of argument. Is like, okay, I could theoretically buy 20 different isolates that are whole bugs, so I can take it through all the way through extraction to the very end. And if they happen to already have, you know, data deposited in NCBI, you could pull that and say, I'm going to use this as the gold standard.
Nick, I think you bring another perspective. Rather than validate, you know, or to show CLIA that we can capture the variant, can we do something like we purchase, you know, like you said, the virus from BEI, and because they got those virus sequenced, and quote unquote, we treat them as the gold standard, as long as we can prove our sequence is matching with their sequence, then it shows our capability to perfectly replicate or map out every single NT. Then not only we don't need to care about variant of concern validation, we basically validated the sequences itself.
Right. It's more important that your workflow can report out variants and not a specific variant, unless it was, you know, either hard to sequence, or if you were doing, like I said before, how many repetitions of a region for, say, Huntington's disease, and you might want to do something like that. You probably also want to do some sort of LOD, but we already know that most of the protocols, after you hit like 32, 33 CT, they crash out and don't work anyway. So that would be part of your QA program to say, I can only use this on, you know, things with a CT value of 32 and lower.
Yeah, I think that's what's in my mind. I don't even want to look at CT value larger than 30. Yep. So my starting material will be less than 30. Yep. And I think Glenn bring a good point is they're not even validated, CLIA validated with the BEI.
Yeah.
Sean, by the way, Sean, what you were suggesting, that's exactly what we did for our original CLIA validation when we confirmed that we can correctly call all the base calls, and therefore we don't need to worry about specific variants when we were just doing the core lab validation. And another kind of workaround, because we use ATCC strains that had genomes available, we used them as the gold standards, but they were generated by old methods which were not perfect themselves. So we did see the SNPs, but to justify that it wasn't our fault, it's just the method variation, we did use the fact that we do replicate and there are errors in the genome sequence are random. If you're able to replicate the same discrepant SNP with your gold standard 5 times in a row, it means you're correct, you're not wrong. And that's what we did, and our CLIA validation did pass.
Yeah. Maria, then your validation is towards virus or bacteria?
Like that was bacterial, but it was the whole genome. Like we validated our ability to call the base calls correctly. That's what we did.
I think I'm not sure this will apply to bacteria because you have, you know, let's just say you have your 5 million base, and you know there will be gaps, random gaps here and there, and are you going to set up like a certain threshold to show you can, let's just say you can achieve, you know, 80% of your your base is identical with your gold standard?
Yeah, well, you do use the genome covers still as a part of your validation. That's something that you validate. And then, of course, there's a downstream assays that you're validating. So you're showing that based on the base colon accuracy that you validated and the coverage, you are able to generate accurate results in your downstream analysis. And that's all it matters. And then, of course, you have to validate it every time you introduce new type of assay. That's still this set of the quality standards that you apply to your base the sequences is still gives you accurate results in your downstream assays. So that seems to have worked for us.
Yeah, I would almost equate it to the way, like, if you were to do vancomycin resistance PCR, it's clearly written in CLSI documents, you must use these 2 organisms as your positive controls. And if we're going to design an LDT to do COVID variants, and there's no CLSI document saying use these 2 or 3 controls, you could say, I would like to use ATCC strain A, BEI strain C and twist positive control 1, 2, 3. And as long as you can, use those and consistently see whatever variants they have in there, that should be good enough. Because it's an LDT, so you get to choose what you're gonna, use as your positive control.
But then,
once CLSI says you must use this reagent as a positive control, all bets are off. Then you have to use that.
But then, I mean, still the question is, yes, you choose your ATGC or ATCC standard strain, but if, or the BI, but do you need those to be CLIA validated first before you can use it?
No, because the ATCC isn't CLIA validated. They fall under like GMP and all those other types of regular ISO to say this reagent is this or this reagent has this specific mutation.
But how about
By the way, we
CDC?
just got cited on that.
but how about CDC? Is CDC cultural, for example, like B117, and then they can send out aliquots of viruses to us to serve as starting material or like validation material? Do we know that?
I can be ears for the agency. It's outside my group, but I know that there are several folks here on the call from CDC who can also serve as ears for your questions and concerns in regards to SARS-CoV-2 variant sequencing under CLIA. I kind of like the way you guys described. I think it was you, Nick, and you, Vivara. You're almost building you're creating a box, and you're saying, I can confidently call this variant if it meets the parameters for this box.
Yep.
I like that.
And you aim for 95% plus or minus 3 standard deviations, and you design your statistics around there. And then you say, okay, I have this variant or whatever variant, it doesn't really matter, but I need to see it so many times. I need a certain depth. I need to not see, so many other different variants next to it. So I know that the chemistry is okay. And I know that, that if it meets those first 2 things, I don't want to see spaces in my assembly. So it's not next to, a bunch of ends or a bunch of like, maybe I have 2 reads, if we want to go outside of variants. Or 2 contexts to say, okay, I know the chemistry is correct because I see it's only 1 or 2 point mutations right here. I don't have, other regions that if you look at the data on, IVAR or CLC or wherever, you could say, okay, physically looking at, what the reads look like, I can call that with confidence. Outside of whether or not the machine is calling it, you can say, okay, it passes the straight face test.
And Nick, your 95 plus minus standard deviation will be the genome covered. Like what's your description here?
I don't know. I just use that for everything because you can't be perfect. If you're perfect, then your quality program is too wide. That's the clinical chemist in me. Yeah, I don't know. I mean, maybe it is. I mean, a lot of the stuff we do does hit 100%. If you're looking for a specific gene in CRE and it's KPC and you sequence 100 KPCs because you got them 5 years ago and you hit them 100%, you hit them 100% of the time.
Any more questions on the SARS-CoV-2 sequencing?
I just want to say thanks. I have to pop off. Thank you very much for inviting me. I'm not a bioinformatician, so I was a little nervous about being surrounded by all of you. So thank you. And Nick, if it's okay, I might email you just to kind of pick your brain a little bit about some of your ideas.
Okay, yeah.
All right. Thank you very much. Bye, guys.
Thank you so much, Marianne.
Thank you, Marianne.
Bye.
I was thinking that maybe we can, we actually kind of went through the majority of the topics on our slide, but I feel like the bioinformatics pipeline compliance is something that is still applicable to the SARS-CoV-2 sequencing, and it would be great to discuss that topic, if you don't mind. So we were wondering if you could comment on your compliance for your bioinformatics pipeline or software. How do you do version controls? Is there any specific safeguards that you have against accidental modifications that you could demonstrate to CLIA inspector? And also, for example, do you have any data analysis worksheets that what information is reflected on that one? And also, overall, do you use the controls for your bioinformatics pipeline portion, specifically in silico controls? Please let us know what your experience is.
In main, we use CLC Bio, and you can actually lock the workflow so no one can change it. So that's what we use, you know, and I'm the sysadmin on that, so no one else can modify that. We do have worksheets for everything. You know, they're writing down expiration dates or date opened or, you know, lot numbers. That's, we treat it like, you know, a PCR assay or anything. We also have a running Excel sheet with all the metrics we sort of want to look at, and it's not so much, it's also not just a specific sample metric, but we're looking at run metrics and then runs over time. So if all of a sudden you see, you know, something's slowly failing over time, we might take a look at that. Most of the time we don't even look at it, but at least you can see over time, and it's all color coded. I showed it once. It looks very ugly, you know, because it's gigantic. We're thousands of lines in and hundreds of rows deep. And we have a couple different, we have a different one that looks like it's slightly different for metagenomics because, you know, I don't know what the starting, you know, genus or species is. So we got rid of those and put some other metrics in there as well.
And for Minnesota, we, for bioinformatic analysis, we always have positive and negative controls. And we also lock down our pipelines. And for each bioinformatic analysis, we actually set up like 2 folders. One is a positive control set, and the other is negative control set. And for each bioinformatic analysis runs, we will randomly grab 1 positive control and 1 negative control and push with our to be analyzed specimen together through the bioinformatic analysis. And see if, you know, the result match with our initial validation. And if it's matched, we're good to go. That's our experience. And our CLIA inspector seems to be quite pleased with this practice.
That is in silico control, right?
Say it again?
Pretty much. It's in silico. It's not the sample that you actually sequenced in your.
Oh yeah, it's in silico. Yes, that's correct.
Okay. And Nick, sorry if I missed that. What you using in silico controls?
So yes, so for so we have 2 assays that is running on CLIA, Salmonella serotyping as well as the strep pneumo serotyping. For Salmonella, we have a set of 17, I think, positive controls, FASTQ files essentially that we previously confirmed by the gold standard, and then their antigen type sort of like cover most of the existing known antigen types. So, you know, you have some weird bugs, Salmonella St. Paul, Salmonella typhimurial, you know, those like antigen like I forgot like how to write it, but we have a diversity of that.
Mm-hmm. And how do you document that you actually reviewed the results of all your 17 controls?
Oh,
is
that's
it
actually
automated
quite
or
funny.
it's a person?
No, it's so our report will lay out all the results, including the negative and positive control, and the file name of positive control is actually the answer. So you will see, you know, this is the file, like the positive control is, you know, Salmonella, for example, Salmonella St. Paul dash positive control number 2, and then your analysis result is St. Paul with the serotype. So then voila, you matched.
Sure.
And are you using like Docker in your pipelines, and you have like specific, I don't know, tags or something on it, or how are you ensuring that you're like version control and stuff like that, or is it just kind of you have it kind of documented what version of whatever pipeline you're using?
We use Singularity, and we run a quick sort of like re-verification data set, of course, in silico, every time we have a software or pipeline upgrade. And we just write a quick blurb documenting it. And I think the feedback from our CLIA inspector is, as long as you have it documented and can show each steps to ensure quality, and that they're fine with it.
Okay.
I was wondering, well, also, I guess the first thing I just wanted to mention that if you haven't read it yet, there's a wonderful guidelines document available from APHL on the bioinformatics pipeline documentation standardization, available at the CDC's and GSQMS Toolkit website, and it was presented by Kelsey Floric at the ASM virtual webinar about a month ago. So great resource. I was wondering if anybody have started using it or have considered your documentation and tracing of your bioinformatics pipeline. And in this case, did you still decide to have the in silico controls in your bioinformatics pipeline, or were you able to justify only documenting exactly what's happening with the pipeline at every run?
I think I've downloaded those documents, but I don't think maybe I incorporated some of them to our QA program, but I should know what our QA program says, but we've had our QA program for 4 years or so for whole genome. So.
Okay. And sorry, so you're doing the controls then in your bioinformatics?
Oh, so we don't have any in silico controls. No, we do have when we use CLC, if we ever need to, like when we just updated the workbench and we have already figured out what steps in our workflows, we would have to sort of do like a mini validation. And depending on what it is, so, if you're updating a database, there's no really sense to do a whole validation. You're just saying, okay, I had 100 genes that I wanted to look at, now I have 101. It doesn't affect any of the other data. If they were to fundamentally change their assembler, I probably have to revalidate my entire workflow. But as you get further and further in the workflow, it doesn't make any sense to validate the stuff above the workflow because none of that changed. It's just everything below it.
Okay, that makes sense. Just a follow-up question. So if you don't have the control that goes through the bioinformatic analysis pipeline, how do you justify to CLIA that the requirement that control has to pass through all the analytical process? How do you address that point?
So we addressed it in our validation where we took the same sample and ran it 10, 20 times through and showed that the results were the same. And as long as I don't modify anything, I'm going to assume it's locked and, and it's not going to change. It's not like a pipette where if you hold it a different way, you've now introduced, 10% variability, which might affect your LOD.
Thank you. If no one has a questions, let's see. Actually, maybe I can still sneak one more question, which is about the wet lab part. I was wondering if you're using the automated DNA extraction instruments, let's say CLIA, and you have to perform multiple DNA extraction runs on the extraction instrument when the samples are included into one WGS run. Do you include the control in each of these runs? For us, for example, CLIA only 12 samples at a time. We have to run it 3 times to have our 32 sample run. And what we noticed that the runs are independent. So it is possible that one run will fail on one day while on the same instrument, while another ones will be fine the same day. Fortunately, happened to us. So how do you deal with that? And do you have just one control or multiple ones?
Being a small state, most of our runs are like 6, and we can do a manual faster.
Yeah, I'm jealous.
Yeah, you know.
Okay.
That's how we get around it. We have almost no samples to run.
Perfect. Anybody? Yeah, well, I'm glad that nobody has this problem then. So, last call for questions. Okay, well, if there's none, again, thank you all the panelists again. I feel like we have, yeah, pretty long conversation. If there's any need, I know there's a few more questions that we hope to address, maybe IQCP, which partially was addressed, but also proficiency testing and revalidation. Maybe we can just have a follow-up call at some point, like a month later, when we have also more things to discuss. And again, thank you so much to all the panelists for your input and everybody else on the call. It was a great discussion. Actually, I do want to add just like a remark from myself for the end. To be honest, I don't enjoy the CLIA compliance for NGS topic at all. The CLIA does not apply to whole genome sequencing pretty much in a lot of cases. And in certain things, the old standards is actually not even the best standards to make sure that the NGS results are accurate in the end. Doesn't make sense, especially with controls and with bioinformatics pipelines. But nevertheless, just my feeling in real world, it will really depend a lot what CLIA inspector you have and what they're reading of the CLIA. And some labs might be great at explaining what you're doing and be able to convince not to do the negative controls or positive controls in your run. Some labs might actually get cited exactly for the same workflow, which we did. And that's why, for myself, I feel like until there is actually amendments and corrections to the CLIA to address the NGS samples, I would personally try to be as close as possible to the CLIA regular standard interpretation until we'll be able to do IQCP, just to give us a peace of mind, like higher chance of passing the CLIA inspection without the citation. But then on the other hand, just to say that CLIA is sometimes overly excessive with the requirements, but it doesn't mean that it's useless. It's still a good way to ensure that your data is of high quality. And I know there was a lot of back and forth about, well, if it's an epidemiological test, why would you even need to comply with CLIA? Why would you need to validate? I mean, sure, don't have it under CLIA compliance, don't report it, but kind of it's a good way to follow general CLIA template to validate your test, just because you need to be sure that they're accurate. That's just my 2 cents, I guess.
Yeah, we actually, after our inspection 2 years ago, we prepared a couple documents for our inspector. She was going to present them at this past year's big CLIA, where they were going to, annual CLIA meeting where they were actually going to talk about NGS. It was canceled because of COVID. So, and she was going to use our IQCP and our method of not using controls to sort of make the point that sometimes controls can be, an OD reading is a perfectly good control for an extraction.
Well, fingers crossed that they really listen to you.
Hope so. I hope so.
Good luck to all of us.
Yeah. All right. Bye, everyone.
Thank you so much.
Well, so just to let everybody know, these recordings will be available on the StaPH-B. There's a private YouTube channel, and so these will be available there. Again, thank you to everybody who was on the call. It was a great discussion, and I really appreciate everybody taking the time out of their day and staying an extra half hour to discuss all these topics with us. So I hope that people found this somewhat informative and useful, and have a great weekend, everyone.
Thank you.